Guys, today we're going to talk about limiting reactants. So again, remember it's very important that you understood stoichiometry before we start this unit or this section. So remember when we did the pancakes last class, we talked about this being our equation and how much we needed of each ingredient to make 5 pancakes. Now though, we're going to have different amounts of our starting substances. Okay, so we have to solve each of them to the pancakes. So when you think about it, if I can make 15, 25, and 40, that really means I only have enough stuff or ingredients to make the 15 pancakes. Okay, I don't have enough flour to make 40 pancakes, nor do I have enough eggs to make those 40 pancakes. So when we did that, the flour limited our reaction. So the flour is called our limiting reactant. That is the reactant that's all used up and that gives us the smallest answer, which we call the theoretical yield. That's how much I actually can make with my different ingredients. Okay? If I were to ask you what are the excess reactants, they're the eggs and the baking powder. Okay, the actual yield is the amount of product that we produce in a chemical reaction, so the actual amount. And in lab, it is generally less than the theoretical amount. So here they said they burned some pancakes and 1 fell on the ground. So while we could have made 15, they only made 11. All right, so let's do a problem. So the key to knowing it's a limiting reactant problem is that there are 2 givens instead of 1. So they want to know what is the limiting reactant and the theoretical yield of aluminum chloride in moles. So we've got our 0.552 moles of aluminum. We're going to solve that to moles of aluminum chloride. And remember, the numbers come from the coefficients. So this number is just the same. Okay. Then we're going to do the other one. 0.887 chlorine. I do have 3 moles of chlorine for every 2 moles of aluminum chloride. So this one requires some math. I get 0.591 moles of aluminum chloride. Okay, so my smaller answer is the one that's my theoretical yield. And my starting point is my limiting reactant. The starting point that gave me that theoretical yield. Okay, so I know this is a little different. It's okay. But again, the smallest answer is the theoretical yield. The one that gave me that is my limiting reactant. Okay, so let's do another one. I've got 3 moles of fluorine, moles of sodium, trying to find moles of sodium fluoride. So 4.8 moles of sodium, do our mole ratio. And we do our other one, 2.6 moles of fluorine. That one's just 1 mole because there's no coefficient. And that one gives us 5.2 moles of sodium fluoride. So smaller answer is my theoretical yield. This Na is my limiting reactant. Okay, percent yield, that is a percentage of the actual over our theoretical, and we multiply it by 100 because it's percentage. So in our pancake scenario, we actually got 11. We could have made 15. We got 73% of our pancakes. So again, actual yield is always going to be determined experimentally. So generally that means we're going to tell you what that is, or we're going to tell you in an experiment, this is what actually happened, something like that. So we still do our mole ratios. Okay, we find our theoretical yield and our limiting reactant. Then, I don't know what's happening, sorry y'all. But in reality, we know that we don't do moles in real life normally. We normally do grams. So most of these are going to take 2 mass-to-mass calculations. So here it's going to walk you through it, and then we're going to do one. So we walk through both problems. We pick our smaller answer. Limiting reactant is that one. Then it tells you its actual yield. You divide that by the theoretical yield and you multiply it by 100. You do need to make sure you write down this equation. It will be used. It'll be used if we ever get to do a lab as well. Like a real lab where y'all get to touch things. Okay, so they're doing some more. Okay, let's do one for us. What's the maximum amount? Okay, so that is the theoretical yield. Sometimes they word them differently. That's okay. In grams, from 45.8 grams and 12.4 grams. So again, we're going to do 2 mass-to-mass calculations. We're going to ammonia. We do our second one. 12.4 grams of hydrogen. Okay. Hopefully you realize that this part from here on, those are going to be the same in both problems because we're solving towards the same product. It is very important that you solve to the same product because if you don't, you can't compare them. It would be like comparing apples and oranges, which is not useful. You have to compare apples to apples or oranges to oranges. Okay, so remember our theoretical yield is our smaller answer, and that makes our limiting reactant nitrogen monoxide because it gave us the smaller answer. Okay, let's do another one. Again, what's the maximum amount, so theoretical yield, of ammonia from 25 grams of nitrogen and 8.2 grams or 2 grams of hydrogen. So, okay, I did notice that some of you weren't putting 1 mole there. The only time it is not 1 mole is in the mole ratio. And that's when we have 2 moles like a mole on both sides of the conversion. .7 grams. And 47.4 grams. Okay, so again, our theoretical yield is our smaller answer, and then our limiting reactant is N2. Okay, if y'all have any questions in this, you absolutely need to reach out. You need to ask questions, you need to come to tutoring. Okay, they also have one in kilograms. I'm not going to work that one, but it's worked the same way. It's just your answers are in kilograms instead of in grams. Okay, so now it's giving us 3 numbers. Now, the thing with this is it's asking for the percent yield, so one of these is an actual amount. We've got 11.5 grams of carbon, 114.5 grams of copper 1 oxide, and then it says this much copper is obtained. This is our actual value. So we're going to ignore that for now, and we're going to determine our theoretical yield just like we've been doing. Okay, it does mean we have to solve 2 copper, and that's because they gave us an actual value of 5. Okay, we've got 143.1 grams of our copper 1 oxide. 1 mole of that. From our balanced equation to 2 moles of copper. Okay, so our smaller value is our theoretical yield. Okay, our limiting reactant is the reactant that gave us that. And then now we're going to do our percent. So the 102 goes on the bottom. 87.4 grams goes on top, because that's our actual over theoretical. We're going to times it by 100. I get 85.7% yield. Okay. Okay, this is another one. If you need to see this one worked out, let me know. But I really want you to be able to try this one without my help. Okay, that is it for today. Please make sure if you have questions, I'll reach out.